The next unit, what we are going to discuss or start with, the topic is probability distributions. Now, what is the need or what was the necessity for for discussing about this probability distributions? See, probability as a whole or in totality has many applications, as we have discussed earlier also, that probability can be used or can be applied in economics. It can be applied for the strategic planning. It can be applied for uh, maintenance or management of the natural resources, gambling, agriculture, computer science, etc., etc. So these are the probability distributions which arise from the various concepts what we had learned earlier. These probability distributions will surely help us to get to know the actual real world life situations which occur in our day to day life. So these probability distributions are also categorized into two parts. One of them is applicable for the discrete random variable, and other part of the probability distribution is applicable to the continuous random variable. Now, in the previous so many lectures, we were continuously talking about the kinds of random variable. One of them was the discrete random variable, other one was the continuous random variable. Whenever the variable is countably infinite, we identify that as a discrete random variable, and whenever it is uncountably non-countably infinite, we term it as a continuous random variable. So similarly, in probability distributions also, whatever various types of distributions we are going to discuss or learn under this particular topic or heading, they will be also categorized as per the random variables nature. Either it will be applicable for the discrete random variable or it will be applicable for the continuous random variable. So accordingly, we will be having many of the things related to those. Now, how these problems will be solved? In most of the cases, the problems will be given to you as word problem related to the situation or pertaining to certain condition, and accordingly we will be trying to judge or identify what kind of problem it is, how the random variable is working, and what kind of distribution will be applied. So from the list of 5 to 6 uh, standard probability distributions, there are a lot many in statistics related to the stochastic variable, but as per the requirement of our syllabus, we will be dealing with very few of them, that is 5 to 6 probability distributions, also which are very easy to solve as well as identify because they are formula based. So the very first part of the probability distribution which will be applicable to the discrete random variable. Discrete random variable means whenever it is countably infinite, we term that particular random variable is a discrete random variable. So in the first part of the unit, we will be talking about the probability distributions which are related to the discrete random variable, which can be counted, which can be seen, which can be measured. So those are nothing but the examples related to the discrete random variable. The very first distribution, very first probability distribution related to this is binomial or Bernoulli's distribution. It is called as binomial or Bernoulli's distribution. Now, what do you understand by Bernoulli's or binomial distribution? Here, it is said that if x is a discrete random variable and let p and q, what are p and q? P and q are nothing but the measurement or the results or the outcome, whether the result is going to be the success or the failure. Now, how you determine whether it is a success or it is a failure? See, as per the given example, whatever is asked to calculate or obtain, or depending on the event or the situation, uh, we identify that the whatever required outcome is there, it is nothing but the success. And whenever we do not get the required outcome, we call it as a failure. So in the discrete random variable case, wherein I will be applying the binomial or Bernoulli's distribution, there will be only two possibilities. What will be the two possibilities? The two possibilities will be only failure or the success. As per the given language of the word problem, the desired outcome is in lines with the required output. We say that it is a success. If it is against that, or opposite to that, we call it as a failure. So we know that success plus failure will together comprise of that particular probability, and probability never exceed 1. So accordingly we will be having success plus failure, that is p plus q is equal to 1. So how will be q obtained as? Q will be obtained as 1 minus p. So p and q, where p plus q is equal to 1, p is equal to 1 minus q, or q is equal to 1 minus p, denote the success and failure respectively of the random variable. So here p will denote the success and q will denote the failure of the random experiment, and accordingly we will be simplifying it as per the given situation or the event given, event provided or the data provided in the word problem for a certain random experiment. So always remember that in binomial or Bernoulli's distribution, binomial expansion का जो statement है उसी पर से derive होता है this binomial distribution or the Bernoulli's distribution. So in Bernoulli's distribution only there will be two possibilities, either which will be success or a failure. Those are represented by P as well as Q. P stands for success, Q stands for failure, and accordingly we will be having P plus Q is equal to 1. Now what will be the formula for this calculation? If the experiments are independently repeated n times and x represents the number of success, and x represents the number of success in n trials, that is x is equal to 0, 1, 2 up to n. This is how the value of x. See here it cannot be infinite because certain experiment is to be performed whatever many times, that should be finite. So in general I am taking it as an n trial. I am not knowing right now that how many times that particular experiment will be performed. So if the experiment is independently repeated n times and x represents the number of success in n trials, that is x is equal to 0, 1, 2 up to n, then x is said to follow a binomial or the Bernoulli's distribution if its probability function is. Now what you have to calculate over here? Here you have to calculate the probability function. What is the probability function given by? For the discrete random variable, it is denoted by small f of x. We always say that it is small f of x, and this small f of x is nothing but probability at x equal to x, and how it is obtained as ncx p to the power x into q to the power n minus x, where x is varying from 0, 1, 2 up to n. So how to calculate this probability function in case of binomial or Bernoulli's distribution? It is probability function is given by f of x. Ultimately मैं क्या निकालने वाला हूँ? I will be calculating the probability function or the probability for a random variable x equal to x. What is that random variable? That is the expected or the desired output as per the required problem. So the formula is ncx. It is in lines with, as I told you, binomial expansion theorem statement. So ncx means out of n trials, whatever are the whatever is the experiment conducted for the n trials, x denotes the number of success. So accordingly ncx, I will be interested in calculating the desired output, which I will be treating it as a success. जो भी आपको आंसर निकालना है वो सक्सेस ट्रीट करिएगा, सो दैट इट विल बी ncx p to the power x. P denotes the success, probability of the success for the given random experiment. So p to the power x, remaining will be q, which is the probability of the failure, and n minus x means n is number of trials, x is number of possibilities for the success which is subtracted. So I get q to the power n minus x, and this x is valid for 0, 1, 2, 3 up to n. So accordingly, we will be having this quantity as the formula for calculation of the probability function. So I hope everybody has understood with the probability function formula. F of x is equal to probability at x equal to x, which is ncx p to the power x q to the power n minus x, x is equal to 0, 1, 2, 3 up to n. The discrete random variable x having the probability function f of x is said to be binomially distributed. So whenever any random variable x fulfills or satisfies this particular formula, I say that this random variable has is satisfying, or this random variable or the probability function is binomially distributed. Why I am saying binomially distributed? Because only two possibilities are there. Either there is a success or it is a failure. So that is how we identify the problems or the examples related to the Bernoulli's or the binomial distribution. Now, there are certain various properties related to the Bernoulli's or the binomial distribution. Just now, I have seen that f of x is probability at x equal to x, and it is given by ncx p to the power x into q to the power n minus x. If random variable x is binomially distributed, then mean value of x, mean value or the average, or it is also called as expectation, which is given by or denoted by mu. Mu is equal to n into p. N into p means what is n? N is number of trials. What is P? P is the probability for the success. So how is mean value? Mu or expectation is given by mu is equal to n into P. How is variance given by? Variance is sigma square. Sigma square is given by NPQ, the product of number of trials, probability of success and probability of failure. The variance of x is sigma square is equal to NPQ. The standard deviation of x, we know that standard deviation is nothing but positive square root of variance. So standard deviation of x is given by sigma, which is under root of npq. Whatever is the variance, that is sigma square, positive square root of that is nothing but your standard deviation. So standard deviation of x is sigma, which is under root of npq. Also, we learnt about the various terminologies, that is moment generating function. So how is the moment generating function given by the random variable which is binomially distributed? It is mx of t, that is moment generating function for the random variable x is q plus p into e to the power t whole raised to power n. Whole raised to power n means number of trials. How is the characteristic function? You learnt that characteristic function is obtained by replacing t is equal to iw in the moment generating function. So characteristic function phi w is q plus p into e to the power iw whole raised to power n. That is how we replace a t by iw to get the characteristic function. Coefficient of skewness, these are also the quantities which are related to the measures of the dispersion. So coefficient of skewness alpha 3 is denoted by q minus p upon under root of npq, and secondly we have coefficient of kurtosis, that is alpha 4 3 plus 1 minus 6 pq upon under root of npq. Coefficient of skewness and kurtosis comes under measures of central tendency and dispersion. So these are the terminologies or the quantities or the properties which are related to the Bernoulli's or the binomial distribution. Is this point clear to everybody?